set of notes, hopefully, for this learning target are these last three examples. Now, I again notice the same thing I noticed on this one. I don't already see opposites, so I can't just add these equations together and eliminate or get rid of one of my variables. So I'm going to throw parentheses around this. Ignoring the positives, negatives for a moment, if this is 5 and 6, flip them, multiply by 6 and 5. Then I check my signs. The signs were different already, so I can multiply both of these by positive 6 and positive signs, and I'll still have different signs. Whereas notice back on one of the previous ones, they were both negative, so I had to multiply one of these by negative to create different signs. So 6 times 5x is 30x. 6 times negative 5y is going to make this minus 30y. And 6 times negative 10, so equals negative 60. 5 times negative 6x is negative 30x. 5 times positive 7y makes this plus 35y equals 5 times negative 7 is negative 35. So I'm going to add these two equations together. 30x plus negative 30x is 0. Negative 30y plus 35y is 5y. Negative 60 plus negative 35 is negative 95. Dividing by 5 to solve for y, I get y equals negative 19. So my answer is going to have the y value of negative 19 in my ordered pair. I'm just going to take my first equation from the original equations, 5x minus 5y equals negative 10. I know y is negative 19. So 5x minus 5 times negative 19 equals negative 10 becomes 5x. I treat this as a negative 5 times a negative 19, so it becomes plus 95 equals negative 10. I'm going to subtract 95 from both sides to eliminate that constant on the left, and I get 5x equals negative 105. Then when I divide by 5 to solve for x, I get x equals negative 21. Now, I am going to show the checks on this one because you do have to check your answers, and I want to make sure in at least every video somewhere I've checked something, hopefully. So, I think my answer is negative 21, negative 19. My checks, I'm going to take my first equation and substitute negative 21 for the x and negative 19 for the y. So 5 times negative 21 minus 5 times negative 19. That really is a negative 19. I'm checking to see if that does equal negative 10. I grab my calculator. 5 times negative 21 minus 5 times negative 19. It equals negative 10, which is, hey, the other side was already negative 10. It does check in that equation. And then let me change the color here. For this equation for the check, negative 6 times negative 21, sorry, I don't know why it's doing that, plus 7 times negative 19, again, I'm getting those values from my ordered pair, from my x and y, does that equal negative 7? Take your calculator, negative 6 times negative 21 plus 7 times negative 19 equals, you get negative 7, it equals the negative 7 on the other side, so it checks. So if I graph these two lines on the same graph, they would intersect at the point negative 21, negative 19. Now, on these, I'm not going to show any checks, but I also said your special cases. So I'm expecting one of these to be infinitely many solutions and one of these to be no solution. What leaps out and bites me on the nose as soon as I look at these, they're different than these because I notice, hey, if I take 5 times negative 2, I get negative 10. 3 times negative 2, I get negative 6. So I'm multiplying the same. If I just multiplied this first equation by negative 2, I get negative 10x minus 6y equals negative 20, not negative 12, but still, same thing here. If I just multiplied this equation by negative 2, and it doesn't always have to be negative 2, but it has to be the same number, I get positive 6x minus 8y. Hey, that works in both of those. That's what lets me know this is going to be a special case. Now, I don't have opposites to be able to add this together the way it looks, so I'm just going to do the same method. It's going to be larger numbers than you have to, and if you see a more efficient way to solve these, please do so. I'm just going to say 5 and 10, flip them, 10 and 5. This would be a positive 50x. This would now be a negative 50x, so I have the opposites I need. So 10 times 5x is 50x. Positive 10 times a positive 3y is going to make this plus 30y. And positive 10 times positive 10, so equals 100. 5 times negative 10x is a negative 50x. 5 times negative 6y, so minus 30y. And 5 times negative 12 equals negative 60. When I add these two equations together now, 50x plus negative 50x is 0. 30y plus negative 30y is 0. This whole side is 0. 100 plus negative 60 is 40. Now I'm going to come back to that in just a minute. Let's do this one. 3 and 6, so flip them, 6 and 3. Check your signs. Yep, this will be a negative 18x. This will be a positive 18x. So I did create opposites. So distributing, I get negative 18x plus 24y equals negative 42. Positive 18x minus 24y equals positive 42. So the same thing happens on the left side of the equation that happened here. Negative 18x plus 18x is 0. Positive 24y plus negative 24y is also 0. What changes is this right side of the equation. Negative 42 plus positive 42 is 0. So in both cases, my variables have totally dropped out of the problem, and I get either two things that are never equal to each other, or two things that are always equal to each other. These are never equal to each other, so this is no solution. Which means if I graph these lines, they're actually parallel lines. This one, if I graph these two, they turn out to be the same line. 0 always equals 0. So this one is infinitely many solutions. Okay, please go and do your practice problem.